Oh, I see. Yeah, I'm rolling a single six-sided die a bunch of times and taking means. Right. That's what I'm doing, right?
Mhm.
Okay, so in this first graph, so let's just make sure we understand what we're doing first. So in this first graph here, right, what I've done is I've taken a six-sided, I mean, of course, I'm making Excel do this for me, right? So I've taken a six-sided die and rolled it 5 times. In fact, let me open up a new sheet and let's just actually kind of do this by hand for that one. And that maybe that'll explain that. And then we can talk about what we're actually seeing. I just want to make sure you actually understand what we're doing. So so let me repeat this a few times. So I'll do it 1, 2, 3, 4, 5, 6. Let's do it 10 times. 9, 10. Okay, so, and I'm going to call these trials because I'm going to repeat, I'm sort of repeating an experiment a bunch of times. I'm going to repeat an experiment 10 times. Okay. And what that experiment is going to do is it's going to be to roll a die 5 times, right? Because this is n equals 5, right?
Mhm.
Okay, so rolling a die can be simulated here by just using this function rand between 1 and 6, right? So it's going to roll a 6-sided die, right? So that's one roll and it happened to roll a 6. Okay. Now I want to do it. I want to do it 5 times. So actually, let me insert here and let's say what do I really want to do? So these are like the number of trials across the top, but then I want like the number of wish I could put 2 things in here. So let's say trials is sort of on top, but also the rolls is here, right? So come on. Okay, fine. Don't do what I want you to do. Okay, so this is roll 1, roll 2, roll 3, roll 4, 5, right? So I'm gonna roll 5 times, right? So n equals 5 in this case. Okay.
Okay.
Okay, so here in my first trial, I rolled 5 times, right? So I got a 2, a 6, a 3, a 2, and a 3. That's what I got on those set of rolls, right? Those 5 rolls. That's what I got, right? And then I can put my average down here. Okay, and so let's come over here and say equals average. And we're going to grab those rolls that we had above. Okay. Okay, so that time my average is 2.6. Okay, now I want to repeat this 10 times. So I'm going to take that information there and I'm just going to copy it over 10 times. Right. Okay, so these are my rolls, right? So my second roll here, I got a 6, a 2, a 1, a 3, a 5, right? And my average is 3.4. All right. And my third roll, I got these things, right? You see how that works?
Mm-hmm.
Okay, so that's what I'm getting. And then down here I have the means. Okay, so let me color these, I don't know, green or something. Okay, so these things down here are the means, right? Now what I'm actually plotting here are the means. These numbers here is what I'm plotting. Okay. So let me do sort of a quickie histogram. I'm just going to copy those values that are right there. And I'm just going to say insert a histogram. So I'm going to have it do all the work for me, right? So it's going to make a little histogram. Let me see if I can make it do, I want it to have like, I don't know, 6 bins or something. How do I do this? Oh, I see. I'm hiding what I'm looking for over here. Let's see. It's not. I think it is here. Yeah, number of bins. Okay, so let's make 6 bins. How many do I have? Sorry, how many do I have here? 1, 2, 3, 4, 5. Actually, I have 8 bins. That's going to be too many here. So let me just make. Actually, I'll make 5 bins. Okay. I mean, it's up to me. So there's a little histogram of that data right there, right? So there are 2 numbers in this list right here between 2.6 and 2.96, right? And then that is less than or equal to 2.96. And there's 3 numbers in this list here that are between 2.96 and 3.32, right? So this is like a little histogram. Okay.
So it's like just like what we did today.
It's like what you're doing in chapter 6. Yeah, this little histogram just showing,
Yeah.
just sort of counting, taking the various values here. So the values are going between, what's the smallest I have? The smallest I have is 2.6, right? In this particular case, and the biggest I have is 4.4, right? So these numbers are going between 2.6 and 4.4, and we're just taking that interval and breaking it into 5 even pieces, right? And then counting how many occur in each of those pieces, right? And altogether I rolled 10 times, right? So I've got 2 here and 3 here and 3 here and 2 here, right? So that's the way that's working, right? Okay, and so this is the means that I'm looking at, right? And now we could take the means of the means. So I'm literally, so now that one's funny, right? I got a bunch of numbers down here and just a few up there, but we're rolling so few that the histograms will look a little bit strange. Okay, now I could take, and so this would be the average of these means. Okay, so the average of all the means is 3.08 here, but I could also take the standard deviation of the means. Right, so this would be equal to the ST dev of that same set of numbers, right? So Excel makes all the calculations easy, okay? And let me get rid of some decimal places. Okay, so there's the standard deviation. So this number here has something to do with how spread out the data is, right? So in this case, the data is kind of really spread out here, and we can do the same thing and run like this function F9 and it'll regenerate it, right? So just like you were doing to get it to regenerate, right? So here our means are 2.96 and the standard deviation is 0.77, right? So that kind of means like if I grabbed, if I put all these numbers in a bag, right? And I've kind of reached in and grabbed a number, I would expect to get a number close to 2.96, kind of plus or minus 0.77, right? So this kind of gives me an interval in which I might expect to grab a number out of that bag. Okay, so it's kind of how spread out the data is, this standard deviation. That's what it's doing. But these are the calculations, these are the calculations that are going into the sheet, right? So the same thing's going on here. I think here probably I did that same thing. So you see here, I'm doing it 10 times, right? I think in this sheet, whoops, that's not what I want. I think in this sheet, I did it probably 1,000 times.
Yeah.
To get a better looking distribution, okay? And then I did the very same thing now with n equals 10. So instead of doing 5 rolls, I did 10 rolls, right? And you get this, right? And then with 20 rolls, same thing. So there's like 1,000 iterations of 20 rolls, right? And in each time I roll the die 20 times, I take the mean, right? And then what I'm actually plotting here is the histogram of the means, not of the rolls, but of the means that I'm getting, right? Does that make sense? So it's important to understand what we're doing because we're looking at the distribution of means, not the distribution of the rolls themselves, okay? So that's important to understand what you're actually looking at the distribution of. We're looking at the histogram of the means of 20 rolls, right? So I'm repeating that like 1,000 times. So I have 1,000 data points here, each one of which is the mean of what I get by when I roll the die 20 times. Okay, so same thing here and here, right? Okay, and what you notice, and I think you wrote down what you noticed correctly, the means don't really change much. I mean, they kind of stay around 3.5, okay, which would be the theoretical average, right? If I just, I've got a 1 in 6 chance, I've got a 6-sided die, right? So I guess I don't have that here anywhere, but I've got a 1 in 6 chance of rolling a 1, right? A 1 in 6 chance of rolling a 2, a 1 in 6 chance of rolling a 3, right, etc., right? So we can write this out, right? So I've got a 1 in 6 chance of, and then the various values. So of a 1 plus, a 1 in 6 chance of rolling a 2 plus, I can keep going like that, Okay, but I could simplify this. I could just say times 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? So this is just like 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, right? So this would be sort of my expected outcome if I rolled the dice a bunch of times and then averaged, right? This is what I would expect. I would expect to get 1/6 1s, 1/6 2s, right? 1/6 3s, 1/6 4s, right? 1/6 5s, and 1/6 6s, right? So that when I averaged them, I would expect to just get this number, which is just 1/6 of that sum. Okay, and when I compute that, it's 3.5, right? So the theoretical mean that I should be getting here would be 3.5. And that kind of means if I did this experiment, infinitely often, I would get exactly 3.5. That's kind of the idea, right? There's always some there's always some variance because this, there's a probabilistic thing going on. We're doing a probability when we roll these dice. So we won't get exactly the theoretical mean, but we'll get close, right?
Yeah.
And what the standard deviation is telling us here is how spread out the data is around the expected mean, right? So as we roll more and more times, the standard deviation is getting smaller and smaller, right? And so that means all the data is getting squished more and more toward the middle, right? So so what this kind of means is, here, if I roll only 5 times according to this data, then I would kind of expect to draw out something close to 3.45 plus or minus, 0.84, right? So that's almost plus or minus 1. So basically, I wouldn't be surprised to get 4.45. I wouldn't be surprised to get 2.45, right? Anywhere in between there. If I just reached into that bag of data and grabbed something, that's kind of what I would expect, right?
Yeah.
Here, I'm sort of expecting to get close to 3.45 plus or minus, 0.6, more or less, right? So here I'm sort of expecting to get something between like 4.1 and what, 2.8 or something like that, right? So it's a smaller interval. So when I grab into this bag and grab a bit of, grab a bit of data out, right? Then I'm expecting it to be close to the mean, but I'm sort of more sure that I'm going to be close to that mean, right? And then the same thing here, since the standard deviation is even smaller when I reach into this bag and grab, right? Then I'm even more sure that I'm going to be close to my mean, right? Because the numbers that are kind of far away from the mean are fewer, right? The percentage of numbers that are close to the mean are bigger, right? That's kind of what the standard deviation is measuring. It's measuring how bunched up things are around the mean, right? Okay, so I mean, that's, sort of what are you supposed to notice here? You're supposed to notice that the standard deviation is definitely decreasing as n increases, right? And the mean itself really isn't. The mean just kind of jumps around kind of near 3.5. Maybe it's sort of, let me just run it again. Let me see what happens. This looks a little funny that it stays below here, but I think, yeah, okay, so yeah, so there it jumped above, right? So it does different things, right, depending on what you do, right? And I guess here I'm going all the way out to 100 rolls of dice out here, okay? Right, so that's kind of what you're supposed to notice, is that the mean kind of just jumps around near where it should be. The fewer numbers you get, the less surprised you are if you get a little bit further away from the theoretical mean. But as you get more and more numbers, you kind of expect your values to be closer to the theoretical mean, right? Whereas the standard deviation decreases in sort of a very nice, sort of a very clear manner, right? It's decreasing, basically like, so x to the minus 1/2 is like 1 over square root of x. So it's basically decreasing like you were dividing by the number of rolls, the square root of the number of rolls, right? So like the square root of what's a nice, so like the square root of 16 would be 4, right? So if I rolled n equals 4, I would only be dividing, my standard deviation, I'd be dividing by 4. I would have some number, whatever this number is, right? I'd be dividing it by 4. Whereas with 100 rolls, I'm dividing by square root of 100, which is 10. So that'd be dividing by 10, right? So that this number would be getting predictably smaller as we go out, right? So if I went out to so 100 square would be 10,000, right? So if I went all the way out to 10,000, then I would be dividing this number by 100, right? And that's sort of what I would expect my standard deviation to be. Okay, so it's going down in a very sort of predictable manner, the standard deviation.
Yeah.
Okay, so basically, I mean, the main goal here is to notice that the mean kind of, it jitters around a little bit, but as you roll more and more often, the means are going to pile up around closer to the theoretical mean. That's what you're really supposed to notice. And I think you wrote something like that. All right.
Okay.
Does that help?
Yes.
Okay.